Okay, so we're talking about ionic compounds. These form between a metal and non-metal. So metals are on the left side of the periodic table. That means they have low electronegativities, which means they tend to lose electrons, which really means they get their electrons taken away from them by other atoms. Nonmetals are on the right side. They have high electronegativity, which means they tend to steal or gain electrons. Okay? First of all, we need to figure out what kind of charges elements make. Okay? So if I look at the periodic table, we number all the tall groups. So we start here. This is group 1. This is group 2. This is group 3, 4, 5, 6, 7, 8. All right? So the idea is all elements are going to be most stable when they have a full outermost energy level, which means when they have an outer energy level like one of these elements over here. These do not form ions because they're already stable the way they are. They already have a full outermost energy level. The rest of these elements, however, do not. So here's what happens. They will either gain enough electrons to get like group 8. So we know that the group number is equal to the number of valence electrons, right? I should write that real quick on this. So A group number, sometimes they call them the tall groups, the A groups, is the number of valence electrons. So they will gain enough valence electrons to get 8 or lose all valence electrons, whichever is easier to do. Okay? Whatever is easier to do. So if I tell you some element on the periodic table, and I'll show this back in a minute, but all right, I show you some element on the periodic table like sodium, for example. So sodium is in group 1. So that means sodium could either gain 7 electrons to get 8 or lose its 1. It's easier to lose 1. Why? It involves less electrons. So it's going to lose 1. Now, you have to remember that in terms of positive and negative charge, it's usually opposite of what you think. So we're talking about electrons which have a negative charge. So when atoms lose electrons, they actually become positive. When they gain electrons, they become negative because they're gaining negative charges. So if sodium loses 1 electron, it's going to form a +1 ion, which we write like that. Okay? Something in, say, group 2, like magnesium here, it has 2 valence electrons, so it could either gain 6 or lose 2. It's going to lose 2, which means it's going to have a positive charge. It's going to have a positive 2 charge because it lost 2 electrons. Okay? And since all of the elements in the same group all have the same number of valence electrons, that means any of these in group 1 are going to form a 1 plus charge. Since all of the elements in group 2 have 2 valence electrons, they are all going to form a 2 plus charge. We skip the transition metals. For those, we would just write Roman numerals like you saw in the review game where I put lead 4 a couple times showed up. Whatever the Roman numeral is, that's the positive charge. It's always positive. All right, all the elements here in group 3, they have 3 valence electrons, which means they will either gain 5 or lose 3. Again, it's easier to lose 3. So they will all form a 3 plus. Group 4, realistically, I mean, they could form a +4, a -4, either way. But most of the time, they just form covalent bonds, which we haven't talked about. They don't really lose electrons or gain electrons too often. All right, more so towards the bottom, like with lead And tin might see some losing electrons because we have some more metallic character down here. Lower electronegativities maybe than up here. Group 5, all of these elements, they have 5 valence electrons, which means they could either gain 3 or lose 5. Now, it's easier to gain electrons. If they gain electrons, they become negative. If they gain 3 electrons, they're going to be a negative 3. All of the elements in group 6 have 6 valence electrons, and therefore they will gain 2, giving them a 2 negative charge. All of the elements in group 7 will gain 1 electron, giving them a negative 1 charge. That's how we determine charges. You're going to be given some elements. I'm going to say write down the charge on each of these. About 10 of them. All right? Now, in dealing with writing compound names or writing formulas, I'll start with the naming. So if we see an IDE ending, it is most likely going to just involve 2 elements. Like if I had, oh, I'm sorry. If we see just 2 elements, I went backwards, I was doing a formula. So just something like this. So how many elements are there? There's just 2. How do I know there's only 2 elements? Because there's only 2 capital letters. There's Ca, and then there's F. So I just name the first one, which is calcium, and then I name the second one, which is fluoride. All right. Okay, now if I see something where there's more than 2 elements, okay, that's telling me that I have a polyatomic ion. So if I had something like this, all right, so now I have Ca, I have S, and I have O. When I have more than 2, I'm going to want to look at the periodic table on the back side and look at the polyatomic ions. Most of the time, the polyatomic ion is going to be some combination of the end pieces, or saying just name the first one and then look up the rest of it, figure out what that polyatomic ion is on the back of the periodic table. If I look up SO4, I'm going to see that it's sulfate, so calcium sulfate. The only time that the beginning of the compound is a polyatomic is when it's that NH4 one, ammonium. So you might see something at NH4Cl maybe. That would be ammonium chloride. Second name when it's just an element is always an IDE ending. Okay. Okay, in terms of writing the formulas, the main idea is that you have to make sure the overall charge is 0. So when I told you on the periodic table what charges they make, that's so I can say something to you like, if I had sodium oxide. Okay, first thing I want to check is the ending. Oxide means it's probably just a negative ion of ox, whatever that is. So this would be just a negative ion of oxygen. So I'm going to look up the 2 ions that form from these things. Sodium is in group 1. So like I told you, sodium, all the group 1 elements, they're going to make a +1 charge. Oxygen is in group 6, meaning that it makes a 2- charge. If I combine those right now, they don't make an overall charge of 0. They make an overall charge of -1 because I have 2 negatives and only 1 positive. So that means I'm going to bring in another one of these. Now the charges balance out to 0. So I would write the formula as Na, there are 2, O, there is only 1 of them. A lot of times on these things, what you can do is just take their charges. Like if I said you had aluminum oxide, okay, so aluminum makes a +3 and oxide makes a 2-. This is another technique to use. We just take that number down here and that number down here, and then it works. That's the formula. But it doesn't always work. What if I had calcium oxide? So calcium makes a 2+ because it's in group 2. Oxygen makes a 2-. If I did this, that would be wrong. It would just be CaO, one of each, right? One of each means their charge is balanced, CaO. Okay? I also want you guys to be able to show me what actually happens with the ions. So if I said, hey, we have calcium chloride, show me how this happens. You would show dot structures. Do you remember doing dot structures? Okay. Calcium, it's just a valence electron still, but calcium has 2 valence electrons. So I just do, remember, don't do 2 dots on the side until you do 1 on each. And then chloride has 7. All right, but it's not just going to be CaCl for calcium chloride. I think I gave you the formula, actually. It'd be CaCl2. I gave you the formula. Okay, so what's going to happen? Well, this chlorine is going to take one of these electrons, so I would draw an arrow like that. Okay, the other chlorine will take the other electron, and now everybody's happy. When we write the ions, we put brackets around them. Now Ca still has electrons, but I'm not going to show them. But it lost 2 electrons, so it has a 2+. Chlorine, I'm going to show having 8. It gained 1 electron, so I'll put a minus charge, and I'm going to do that twice. So be able to show these diagrams as well, and I am done.